Hi, and welcome to Geeks for Geeks. Today, we would be discussing the problem named as lexicographically smallest string. So, in this problem, we are given a string which contains only lowercase characters. And what you need to do is you need to remove k characters, okay, from the string and make it in such a way that it is the lexicographically smallest string. So, before moving forward and let us discuss how to rectify before using k, let us first discuss what is lexicographically smallest. Okay, so lexicographically smallest or largest does it just means that dictionary order. So suppose you are reading a dictionary, so a word with AA would be ranked before a word AB, and the word ranked AAC would be ranking before AB. Okay, fair enough. In the same way, a word ranking Z would be at the end. So it doesn't matter the number of characters it has, it just depends on the ordering itself. So now, just before moving forward, let us discuss a small property about this lexicographically smallest string so that you would require this for your further problems too. And what is it? It is that you can just relate it with the bit representation, where we have something known as least significant bit and most significant bit, where the bit on the left hand side matters more than the bit on the right hand side. Okay, in the same manner, suppose we have AA, and if we change this one to AB and we change then this one to BA, so you would observe that this BA would rank much larger than this one. Okay, so we can understand by this that the words on the left hand side matters more than the words on the right hand side if we want to rank the lexicographically smallest one. Okay, like suppose we have A. So if we just alter this A to B, okay, the difference would be a smaller than if we just alter this to B. Okay, so to sum up everything in Hindi, it would be that जो पहले के कैरेक्टर्स उनको चेंज करने से वो ऑर्डरिंग ज़्यादा ऊपर जाता है कंपैरेटिवली. Okay, to sum up everything in Hindi, we can understand that जो लास्ट के कैरेक्टर्स है उनको ऑल्टर करके ज़्यादा करने से वो ऑर्डरिंग में ज़्यादा नीचे जाते हैं कंपेयर. नाउ टू सम अप एवरीथिंग वी कैन से दैट द लास्ट कैरेक्टर को चेंज करके बी करने से हमें कम फर्क पड़ता है, जबकि पहले के कैरेक्टर्स को चेंज करके बी करने से ज़्यादा फर्क पड़ता है, मतलब वो ज़्यादा नीचे आ जाएगा क्योंकि बी ए वो ज़्यादा नीचे आएगा कंपेयर टू ए लास्ट में बी. Okay, this is what I want to convey. Now let us move back to the question. So now, before you start removing the k characters, there is one more thing to understand. Okay, it is given that if the length of the string is a power of 2, okay, then we need to reduce it by half, else we need to multiply the value of k by 2 itself. This is what you need to do. Okay, so now the problem is that how to check if a number is a power of 2 or not. The first is that you find out the representation, test sealed representation, take it by 2 and you see, suppose we have 7. Okay, let's take suppose 8. Okay, so you can see that 2 to the power 3 is equals to 8. You are taking the seal value of it, okay, by using the seal and all. But I think that for beginners it would be a little bit difficult to understand. So what you can see is, if you see the bit representation of the powers of 2, you would see a pattern in them. The pattern is 2 to the power 0 is represented like this, 2 to the power 1 is represented like this, 2 to the power 2 is represented like this, 2 to the power 3 is represented like this, 2 to the power 4 is represented like this. Okay, so you can see a pattern that in all the powers of 2, there is only one bit set. Other than that, everyone is unset. Okay, so what we can do is we can just take the value of n, we can count the number of set bits. If it is equal to 1, we would reduce k by half, that means it is a power of 2, else we would just multiply it by 2 in all other condition. Fair enough. And we need to remove exactly k character, that means even if it is the smallest, lexicographically smallest string, we need to remove characters, whatever be the scenario, neither less neither greater. Okay, please keep this in mind, this exactly thing. Okay, so now let us first discuss this one, fooland. So what is the value of n? N is equals to 1 2 3 4 5 6 and 7. So now 7 is not a power of 2, so we would multiply it by 2. K is equal to 2, so k is equals to 2. If we multiply it by 2, it would become 4. That means in this string we need to remove 4 characters. Fair enough. So now what all characters we can remove? We can see that if we remove this one, this one, this one, this one, then the remaining character would be the largest. Now let us see the same. Here the value of n is equals to 4, as it is a power of 2. So k is equals to 4 by 2, which is equals to 2. And if we remove it, then we can see that we are removing this and this. So now let us move forward and take the same example. Let us take the smaller one, CODE. And here we would take the rectified value of k, which is equal to 2. Okay, because we need to remove 2 characters. So let us see how we can remove the 2 characters. The first is that we want, so let us see the answer. What was the answer? The answer is CD. That means that if we keep the smaller characters at first, it would be more beneficial. So we need to prioritize on having smaller characters in the left hand side. So smaller characters kya kya? Let us start discussing the ordering. This is the smallest. Okay, so I would just have it as 1. This is the second smallest, I would have it as 2. This is the third smallest, I would have it as 3. This is the fourth smallest. Like if we sort this, the ordering would be C, D, E, O. You accept with this? Yes. Okay, fair enough, but we can't sort it. Why? Because we need to keep the ordering. We just need to remove the k characters and then give out the string in the same way as it was given. So now let us see what is the lexicographically smallest string we can make. So if we remove this 4, then we have 1, 2 and 3, which is smaller than 1, 4, 2, 3. So we need to remove the larger values. So first we need to prioritize on removing this one. Okay. After this we have 1, 2 and 3. Now which one should we remove? Okay. Now k is equals to 1 because one character is already removed. So now we can simply say that we need to remove this one. So we can see that it is a kind of increasing order. We have 1, 2, 3. At the end k was 1, so we just remove the last one. Okay, because 1, 2 is better than 1, 2, 3. What do I mean to say is A, B, C and A, B. This would rank first and this would rank second. This is smaller than this. Okay, please remember this. Let us take the second example, which would kind of give the best idea, like fooland. Okay, FOOLAND, and this time we would be taking the rectified value, that is ek is equals to 4. Let us start again. Let us start ordering this. If we just order this, we would have this one as the first one. Then we would have A, B. B is not there. C, D, E, F, G, H, I, J, K, L, M, N, O, 5 and 5. Okay, we have this. So now let us try removing this. When we start removing this, we can see that we need to somehow have this one in the front. Why? Because these are all greater. So we would have this as 3, 5, 5. Okay, fine. K is equals to 4. So if we just remove all of this, then we would have 1. And then from 1, 4, 2, we need to remove one more. Okay. So what is the beneficial one? If you see, the beneficial one would be removing this one. So if you observe that the remaining string would always be in an increasing fashion. Just take one more 2 examples and you would observe that the remaining string is just a increasing fashion. So you can, what you want is increasing ordering. Okay, like you just want the sorted order, okay. And after the sorted order, even if we need to remove elements, we would just remove it from the last, because the last element is the greatest, and we would just remove it. Like suppose we have 1 2 3 4 5, we are having the increasing ordering, and at this point k is equals to 1. That means we need to just remove the last one. Why? Because if we remove the first one, the ordering would be 2 3 4 5, which is greater. So removing the last one is the most cunning approach. So now how can we get the increasing ordering? To get the increasing ordering, and we need to leave the increasing ordering also when k is equals to 0. Suppose we don't need to remove any character. Suppose k is equals to 1 and we divide it by 0 as n is a power of 2. So 1 divided by 2 is equals to 0. So that in that point, whatever string we are giving, be it either ABC or CBA, we need to cope up with that. So we need to have the ordering when k is equals to something. Okay, so what we can do is just think it in this way. Suppose we won't go in form of characters, rather we would be going in form of numbers. Suppose we have 1 5 3 and then 4. So what we can do is, first we don't have any characters and we want the increasing, so we would have 1. Okay, so you can just take it as a given an array of numbers, you need to have an increasing order, and you can only remove elements which is equal to k. Okay, just this one. So now after that we have 5, so we would first keep it 5 because 5 is greater than 1. Next we have 3. Now we have k, suppose k is equals to 2, so we have some value of k, now we can afford to remove. So now 3 is greater than 3 is less than 5. So if we remove this 5, then we would have an increasing order which is cheaper. Next we have 3, next we have 4, and this is the perfect one. After that we have already removed k is equals to 1. K is equals to 1 is removing, and we would remove this. Okay, so now the algorithm is very much simple. We would start including elements from the back, and if the last element inserted, okay, so we would insert elements to back, and we would insert elements in this fashion. If it is empty, so first we would say if it is empty, we would simply insert, like so just remember that the agenda is to get an increasing order. So if it is empty, then we would simply insert one character. Like if we would insert, simply insert. If it is non-empty, what we would do in this scenario, if it is non-empty, we would check that if the last is greater than the current, then remove last till last is less than equal to current. Okay, like suppose we have 1 3 5 and here we have 2, so we would keep removing 3 and 5 until 1 is less than 2. Or suppose we have 2, then we have 7, then we have 8, and then suppose we have 2 again. So in this scenario we need to remove 8, we need to remove 7, and after that 2 would follow 2. So this is removing the last till the last is less than equal to the current value. Okay, after that, even if doing this is an increasing order like 1 2 3, and even if k is remaining, we would remove them, and then we would simply return our answer. So if you observe this, you would find that this question is of stack. How? I would just show you. What are the requirements we have? We need to see the last element. We need the access of the last element. So the first indication is that we need the access of the last, and we need the removal of the last inserted element. So if we want the removal of the last access of the last inserted element and the removal of the last inserted element, this question is offshore of the stack. Okay, fair enough. And then we would just do it. So now let us move to the coding part. But to give it a twist, as you already know that you have stack. and you can use stack to solve this problem in an interview. But suppose this question is given in an online assessment, OA. So what you can do is you can directly use vector, because the back of vector as well as the pop back of vector, like the access of the last element of the vector and the removal of the last element of vector, has the same time complexity as stack, and it gives random access also. So vector is better than stack if you are solving online judge problems. Okay, let us move back to the coding part, and we would solve it using the classical data structure, that is the struct. Okay, so very first thing is we need to count the number of set bits. So we would say count set bits, and we would have int n, and then what we would do is int c is equals to 0, and we would say while n is greater than 0, and if c is equals to c plus n and 1, and then n is equals to n, right shift by 1, and then we would return the value of c. So how is this getting the value? So let us just see what this code does, as it is out of the scope, so I am not explaining how it does. Suppose we have 1 1 0. So what it does is, first this 1 1 0 is greater than 0, so we would come here and we would just simply do a AND with 1, and this value is equals to 0, so this would add 0 to the result. So now c is equals to 0. Next we are doing right shift by 1. So 1 1 0 right shift by 1 would make it 1 1. 0 would be removed, and then we would again do a AND with 1. This time 1 1 is equals to 1. So now c is equals to 0 plus 1 is equals to 1. So now again 1 1 right shift by 1, which is equals to 1. Now AND with 1 would make it again 1. So this would again add a 1. And then after all of this, 1 right shift by 1 would make it 0. And at this point, this while loop would exist, and see, we are getting the number of set bit, which is equal to 2. Okay. So now we are coming at this point of time. We are initializing a stack of character, and we are naming it with st, and then we would be getting the size of the string itself. Okay, and then if the count of set bits 1, then we would say k is equals to k divided by 2. Else what we would do is we would say k is equals to k multiplied by 2, which is according to the given condition. We are just rectifying the value of k itself. Now we go down. Okay, now we would start the iteration for considering each of the characters. Okay, fair enough. Now we would say if the stack is not empty, like we want to check the last element, so first we need to check if the element is present or not, because if the stack is empty and we are checking the last element, then it would give us a segmentation fault. So we are first checking if the stack is not empty, and now we should be ready to remove characters. That means k is allowing us to remove characters, and then st.top, that the last inserted element is greater than the current element. If this is the scenario, so this means that we have 1 and we have 3 and we have 2. This is the current character. So if 3 is greater than this one, then we would start removing it. Okay, so we would say st.pop remove, and we would, as we have removed, we would just decrease the value of k itself. Okay, after all of this is done, we would insert 2. So we would simply st.push s of I. Okay, all this is done. Even after all this is done and we are getting a increasing value, that means we are getting 1 2 3 and k is still equal to 1, that means we need to remove the characters from the last, as I have already told you. So what I would do is, while k is greater than 0 as well as k is not empty, that means k still has elements, we still have elements and we need to remove characters, that means st.pop characters, okay, last inserted characters, and we would have k minus 1. Now we would initialize the string answer, where we would keep the string after all of this is done. So if you observe that in a stack we would have something like 1 2 and 3. So now we would just have 3, then 2, then 1. But we want the ordering as 1, 2, 3. So what we would do is we would first take out all the elements, keep it in a string, and then just reverse it before just returning it. So what we would do is, while the stack has some elements, we would take out all the elements, like answer dot push back the elements from the stack, and st.pop. First we would get the access and then we would remove it. After all of this is done, the stack would be empty and we would be having the result in the reversed form. So we need to reverse it again. So reverse reverse answer dot begin and then answer dot end itself. We are just reversing it. And then after all of this, if there is no string, then we don't need to remove empty string, as it is already told that if the string is empty, then we need to return -1. So we would say if answer dot size is equals to 0, then we would return the -1. Else, okay, or we don't need to write else, because if the control is coming to at this point, we would just return the value of answer. Let us just compile and run and see how many errors am I making. So get ready for errors. Okay, we are getting correct output for the sample test cases. That's good. Okay, we have successfully solved it. So if you observe, so what is the time complexity of this problem? So as there is already a while loop at this point and this is a for loop, then you would think that the time complexity of this approach is big of n square, but it isn't. Because if you just do the dry run in your pen and paper, you would observe that each character is inserted once and taken out once. So at most we are doing 2n operation, and ignoring the constant we are doing n operation. So that means the time complexity of this approach is big O of n. So please just do a dry run for this one and you would understand it much better. Okay. So if you are here till this point of the solution, consider liking the video and commenting on the video for better reach of this video. Thank you and have a nice day.